Bismillahirrahmanirrahim. Assalamualaikum and welcome back to my fun physics world. So today we continue our lesson, Form 4, Chapter 2, Forces and Motion, Part 1. So we look at 2.4, Inertia. Look at these two diagrams showing bus with different motion. So diagram A shows the passengers in the bus move or fall backward. In diagram B, showing that the passengers in the bus are falling forward. Alright, so can you guess what motion is the bus having? Yes, correct. So diagram A showing that the bus is actually at first is at rest and start moving faster. So that is the reason why the body of the passengers move backward. And in diagram B showing that the bus is already in motion and suddenly stop. So that's why the passenger's body move forward. What makes that happen? So this is what we will learn today. This is something to do with inertia. By the end of this lesson, you should be able to define inertia, to relate mass and inertia, to give example of negative effect and the application of inertia, and finally to solve problem. What is inertia? Inertia is the tendency of an object to remain at rest or, if moving, to continue its uniform motion in a straight line. Inertia relates to Newton's first law of motion. There are three Newton's law of motion. So this is the first one, first Newton laws of motion. So it says that every object will continue in its state of rest or of uniform motion unless acted upon by an external force, which means your book on the table will not be moving unless you push the book. A moving car will continue its motion unless the driver steps on the brake pedal. Boys and girls, we actually can have a lot of fun activities with inertia. So these two videos involve inertia.
2, 1. 5, 4, 3, 2, 1.
Okay, are you ready? Okay, start.
3, 2, 1.
How was that? Isn't it interesting? So now, let us discuss the observation and explanation for both activities. Okay, so the first activity, what is your observation? So when the A4 paper is pulled, the glass of water remains stationary. So how to explain this? This actually relates to the inertia. So the inertia of the glass of water tends to remain at rest and resist the motion. Okay, so number one, just now you know that the glass of water is stationary. When the paper is pulled suddenly, the glass of water still stationary and the water does not spill out. So the reason is the inertia of the glass of water tends to keep its initial motion, which is stationary. As for the second video, at first the trolley is moving and the student already placed a wooden block on top of the trolley. So when the trolley moves and stops suddenly, so the wooden block keep on moving forward. Okay, that is your observation. The trolley stopped, but the wooden block continue its state of motion and lurch forward, terhumban ke depan. Okay, so how do we explain this? Okay, we'll need to look at the wooden block. Initially, the wooden block moved together with the trolley. When the trolley stops suddenly, the wooden block inertia tends to keep its motion, means that to continue its forward motion. That is the reason why the wooden block move forward. That is actually the negative effect of inertia. When the car moves at high speed and stops suddenly, the passenger body tends to move forward, lurch forward, because of the inertia of the passenger's body or the driver's body tends to keep its initial motion, which is moving forward. Okay, so to avoid that from happen, that is the reason why we need to use seat belt. So when you use a seat belt, so the seat belt will prevent the body of the passengers move forward. What is the relationship between mass and inertia? Look at these two diagrams. So here is a truck with a mass of 10,000 kilogram and a motorbike with the mass of 200 kilogram. If both vehicle is at a starting point and start moving suddenly, which one do you think is harder to move? Yes, the truck will be harder to move. The motorcycle can move faster. Second situation, if both vehicle is moving at high speed and suddenly need to stop, which one will be harder to stop? Yes, again, the truck will be hard to stop compared to the motorbike. The harder the object to move, the bigger the inertia. The harder the object to stop, the bigger the inertia. So in this case, we say that the truck has bigger inertia compared to the motorbike. And we know that the truck has bigger mass. So the relationship between mass and inertia here will be, we can conclude that the larger the mass of an object, the larger the inertia. Okay, the larger the mass of an object, the larger the inertia. Experiment to determine the relationship between mass and inertia. So this is SPM paper 3 section B question, showing a man pushing a trolley. So he found that it is more difficult to push the trolley when it is full loaded compared to when the trolley is empty. So from these two diagrams, you need to come up with your inference hypothesis, and then with the apparatus such as hexoblade, plasticine, G-clamp and other, so you need to describe an experiment to investigate your hypothesis. So you need to write your aim, variable, list of apparatus material, arrangement of the apparatus, and then procedure, table to tabulate your data, and graph to analyze your data. So this is similar to SPM 2016 paper 3 section B question, but they have different diagram. So it shows two spinning top, one coated with tin. The two spinning top spin, rotate with the same velocity, and they have same size. And then after a while, we can see that the normal spinning top stop faster, but the one coated with tin still rotating. So from your observation, you need to come up with your inference hypothesis. Same as just now, they give you hexoblade plasticine, and then you need to write all of this. This is the marking scheme. So inference, inertia of an object depends on its mass. So you use the word depends. Okay, inertia of the object depended or depends on its mass. Bergantung kepada jisim. Hypothesis, the larger the mass of the object, the larger the inertia. Aim, to study the relationship between inertia and mass. Variable, so manipulated is the mass of the plasticine or mass of the object. It's better for you to write symbol M. Responding variable, it should be inertia, but will be represented by period of oscillation T in this experiment. Constant variable will be the distance between G-clamp, okay, G-clamp and the plasticine. It can also the amplitude of oscillation. And then apparatus, you need a stopwatch, G-clamp, ruler, jigsaw blade. And you also need plasticine with 5 different mass. Okay, it's better to write the mass. Huh? Now, this is the apparatus arrangement. Okay, when you draw an apparatus arrangement, so make sure you label your diagram. Okay, label diagram like this. So procedure. Of course, you need to set up the apparatus as shown in the diagram. Then you can place 20 gram plasticine at the end of the hacksaw blade or the jigsaw blade like this. Okay, then you displace the free end of the jigsaw blade horizontally and release so that it will be oscillating like this. Okay, so the time taken for 10 complete oscillation is measured using stopwatch and recorded. So we normally take two times reading. Then, so the average time for 10 complete oscillation, T average, calculated using formula T1 plus T2 divided by 2. So from here, you can calculate the period of oscillation, capital T, using formula this T average, okay, average, T average divided by 10. Then, step above is repeated with another 4 more mass. Okay, you can need to write that the mass is 30 gram, 40 gram, 50 gram, and 60 gram. And this will be the table. Okay, table. The mass of the plasticine, time taken for 10 complete oscillation, you have your T1, T2, and T average. Then you calculate the period of oscillation, where this period of oscillation is T average divided by 10. You get this. Then you need to plot graph of T against M. So why we put M on the horizontal axis? Because M here is the manipulated variable, should be drawn on the horizontal axis. And then period of oscillation is your responding variable, so you draw on the vertical axis. And this period of oscillation represent inertia. Okay, so you will get graph like this, okay, a curved graph showing that when the mass of the object increases, period of oscillation increases. Hence, we can conclude that when the mass of the object increases, inertia increases. Daily life application inertia. How do you dry your umbrella? Okay, so some students normally rotate the umbrella and stop the umbrella suddenly. So how do we explain that in terms of inertia? So the raindrops on the umbrella are in motion as the umbrella rotates. When the umbrella stops rotating, the inertia of the raindrop will continue its motion and leave the surface of the umbrella, hence the umbrella will dry. Similar to the umbrella just now, dog, cats actually dry their body by shaking the body vigorously. Okay, how to explain that? Actually, the water droplet on the body of the dogs and cats will continue its motion. Who here love to eat chili sauce or tomato sauce? So without realize, you are using application of inertia in your daily life. Okay, so how do you pour the chili sauce from the bottle? So actually, when you move the bottle downward quickly and stop suddenly, so the inertia of the sauce will tend to continue its motion downward. Hence, the sauce will come out from the bottle. We can also pluck fruit from trees by using inertia. So we can shake the branch of the tree, and when you shake the branch of the tree, so the fruit actually moving together. So every time you change the direction, the fruit will continue its motion, its straight motion. Okay, hence it will be pulled out from the branch. So you can enjoy the fruit. This oil tanker has huge mass, means it has bigger inertia. Hence, it will be harder for the tanker to stop on time. To reduce the negative effect of the inertia, the oil normally will be placed in a few smaller compartments. When the tanker arrives at one station, one compartment will be emptied. If they don't have small compartment, so means that the oil will be distributed like this. Every time the tanker want to stop suddenly, so the oil inside here will shake a lot. So this will give huge negative effect to the inertia, although the mass of the tanker are the same. So by using different smaller compartment like this, the negative effect of the inertia will be reduced. Let's say you are being chased by a cow. So what should you do? Okay, so you need to actually run in a zigzag motion. You have smaller mass, then easy for you to change your direction. But then the cow has bigger mass. So bigger mass means bigger inertia. The bigger the inertia, the harder for it to change its motion. Okay, so the cow has bigger mass, hence bigger inertia, making it difficult to change direction. So you can escape from the cow. Okay, we look at some exercises. Which phenomenon shows the effect of inertia? Okay, A, B, C, D. So which one is the answer? Yes, I know you love to eat tomato sauce. That is the answer. When you move the bottle downward and stop suddenly, so the inertia of the sauce tends to keep on the downward motion. Hence, the sauce can be poured out from the bottle. So a body stays stationary or continues to move with a uniform velocity unless there is an external force that changes its state of motion. So which law is explained by the above statement? So the answer is Newton's first law of motion. Okay, answer is A. Diagram A shows an empty bottle rolling when the train starts to move forward. Forward means to the right. No? When the train, this is in the train, so the train move forward and the empty bottle rotate backward. And then diagram B shows an same empty bottle rolling in opposite direction, means move forward when the train stops suddenly. So the train just now is moving forward and stop suddenly. So the bottle rolling forward also. So this situation is due to the, which one is the answer? Yes, inertia. Alhamdulillah, we have come to the end of this lesson. If you follow until here, please comment 3 smiling face. Okay, and then make sure you know how to define inertia. Make sure you know how to relate mass and inertia and write experiment about it. And then give example of the positive and negative effect of inertia and how to overcome it. If you have time, you can also try the hands-on activity, take video and let me know. Okay. Till we meet again. Assalamualaikum warahmatullahi wabarakatuh.